This question is based on operand forwarding. So I'll read the question first. This question is asked in GATE 2010, GATE question. I'll read it first. A 5-stage pipeline instruction, a 5-stage pipeline, instruction fetch, instruction decode, operand fetch, perform operation and write back. So this is exactly the type of instructions, 5 stages we have seen it, right? So here each stage is same. So first one is fetching, means you know what it is, and decoding means you know what it is, and operand fetch means from the register file we are going to fetch the operands that are going to be used and we are going to provide it to the execution phase. Here the execution phase is renamed as perform operation, PO. It is same as execution phase. And in the write operand, in this phase we are going to take whatever is the result of the operation is and we are going to write it back to the either memory or to the register file. Now instruction fetch, all these instruction fetch, instruction decode, operand fetch and write operation, they take one clock cycle, which means everything is going to take one clock cycle other than this perform operation. And perform operation takes one clock cycle for add and subtract, 3 clock cycles for multiply and 6 clock cycles for division. Then operand forwarding is used. What is the number of clock cycles needed for following? So whenever you use the operand forwarding, what happens is whatever is computed in the execution phase will be provided as input to the execution phase immediately in the next cycle, which means once, if there are any dependencies, once an operation finished, once an instruction finishes execution in the execution stage, you can start the execution of the next one without waiting for anything. Therefore, even in case if your operand, this operand fetch, where is it here, operand fetch is going to fetch wrong inputs, they will be rewritten or overwritten by the execution phase. Just now we have seen it, right, in the earlier example. So now let's see how many cycles will it take for us to execute these 4 instructions. One is multiplication, division, addition and subtraction. So if you see this question, first thing is you should observe that each operation is going to take different cycles. So multiplication is going to take 3 cycles in perform operation stage and division is going to take 6 cycles in perform operation stage. Addition and subtraction, these two are going to take 1 clock cycle each. Now so depending on the options you have to write how many ever they are required. So let's start with I0. So I0 has to start with instruction fetch, IF, right? So once instruction fetch is over, it has to perform instruction decode, ID, which is going to take 1 cycle, and then operand fetch, which is going to take 1 clock cycle. And now the perform operation for multiplication, it is going to take 3 clock cycles. Therefore perform operation, perform operation, perform operation, 3 clock cycles, and then write back is going to take 1 clock cycle. Got it? And after this the next instruction divide has to start. Now if you see this, there is no dependency between I0 and I1 because I0 is reading R0 and R1 and writing R2. So if you want to check it, see this, in case of I0 and I1, the domain of I0 is R0, R1 and the range of I0 is R2 and the domain of I1 is R3, R4 and the range of I1 is R5, right? Now if you observe it, the domain of the range of R0, I0 and the domain of I1, these two are not intersecting. Therefore there is no raw dependency here, read after write dependency here. And also if you see this, the domain and this range, these two are also different. Therefore there is no write after write dependency. And also if you see this, the range of these two are also different. Therefore there is no write after write dependency also. So there are no dependencies. So next one you can just execute in parallel and just see that functional dependencies are resolved. Functional dependencies means you have to know to in the same clock cycle we should not use the same phase. Okay, now the next one is second instruction, I1. Instruction fetch, instruction decode, operand fetch, and the next one is perform operation. So perform operation cannot start here because it is already being, first instruction is already using that phase. So only here you can start the performing the operation. So what is the operation? Division, and we know that division is going to take 6 clock cycles. Therefore perform 1 2 3 4 5 6 and finally write back. Right, now I can start the next instruction. So next instruction is it needs R2, right? R2 for reading here. It needs to read R2, perform R5 plus R2, and it has to be stored back into R2. Therefore, if you observe between these two, there is definitely a dependency, right? So here it is trying to write R2 and it is trying to read R2. So therefore there is read after write dependency. So I2 should not fetch the operands until the execution stage of I0. So I2 can it can fetch the instruction, so I2 can fetch the instruction, I2 can decode the instruction, but it cannot fetch the operand until this particular I1 performs the write back, which means ideally you are supposed to start operand fetch at this point, because you are supposed to fetch the value of R2 and it is going to be written by I0 and it is going to be available only after the write back stage. But then since the operand forwarding is provided, you need not wait till that point. You can start it here itself, operand fetch, because even if you fetch the operands wrongly, they will be written back by the they will be overwritten by the write operands because of the operand forwarding method used, right? Therefore, even though you are going to fetch the wrong value of R2 here, later after the execution of this, anyway that is going to be provided, right? So but then it is going to be overlapped or overwritten by this perform operation. So in this case you are supposed to wait. Okay, so why am I waiting here? Even though you can start off this operand fetch here itself, the problem is this instruction is going to write the value of it, provide the value of the output as the input to this if it is required, but then this one is going to overwrite it anyway. That is why you wait till this point, so that, okay, not till this point, write back operand fetch, you have to wait till this point so that writing is going to happen here, which means R2 is going to be available here and this particular value will be fetched here, right? So you have to wait till this point and fetch the operands and you can start execution, but then you cannot start execution until this point. The reason is execution unit is still being used by I1, so I2 can start execution here, and since it is an addition, it will take only one cycle and after that it can write back. Got it? And the next one is subtract. So see this subtraction. So subtraction can start, instruction fetch can start here, instruction decode can start here. Let's see if there are any dependencies. If you see this, there is a dependency here, right? So what is the dependency? R2 has to be read, isn't it? And R2 is written by this one. Therefore there is a dependency. Now how can you resolve this dependency? This dependency can be resolved this way. So you cannot fetch it, so operand fetch, see, our R2 has to wait till this point, R2 will be available only after this point, but because of the operand forwarding method, after this particular operation is done, right, it will be again provided as the input to this. Output of that particular execute can be provided as the input because of the short circuiting. So even if you fetch the operand here, Since you are immediately following this instruction, the output is still available and it can be fed back. That is why you can start the perform operation here itself. The reason is, once this phase is over, once R2 is available here, it is going to write back the value of the R2 into the inputs of this perform operation phase. Here it didn't happen, right, because this one needs the output which is provided by first instruction, but the second instruction is going to overwrite it. That is why we are not able to perform this operand fetch till this point. But here you can perform the operand fetch here and the wrong value will be fetched, but still it doesn't matter because anyway it is going to be overwritten at this point, right, and then you can write it. Therefore it is going to take 15 clocks. So one thing you should understand is, in the execution phase, if you have ALU, if you have the inputs and if you have the output, short circuiting means this, right, the output will be provided to the input immediately. Now if two instructions are there, I1 and I2, and if I1 is just computing something here and is placing something here, and if I2 needs something here, then after the execution phase of I1, I2 can start executing like this, even though the operand fetch has executed long back and it has fetched wrong operations. But in the case if it is like this, I3, if there is a dependency between I1 and I3, and if the output of I1 is required as input of I3, operand forwarding will not work in that case. You have to fetch the operands after this one is complete. Okay, so anyway, in this question it doesn't matter, either you perform it operand fetch, either you place the operand fetch here or you place the operand fetch here, it doesn't matter. Anyway, answer is going to be there, but just be careful with this. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.